glancing over the screen here, it looks like I accidentally got a couple typos in the comments here. I changed the name of that one. But our language is Python, not Python. That kind of caught my eye. Okay, so the next couple methods can be incredibly useful when we have a bunch of data and we might not know while we're writing the program what the data is going to be, but we know what the output's going to look like. So define FillInPlaceholder. We'll make this method for FillInPlaceholder, and here I need to pass in two parameters, some random thing, and I don't know, another random thing. So what can we put here? I'll build the string. So string with empty spots. It's kind of like when I first learned about this one, I thought of those old Mad Lib books. Y'all might remember that. You know, there's blanks in sentences. It's like have somebody give you a noun, an adjective, verb, and you fill in blanks in the sentence, and it's usually quite humorous. This made me think of that when I first learned those. But here, I'll just put it together. Here is, and then to leave a blank, we use our curly braces. So here is just a blank spot. String to fill in another blank spot at runtime. Sort of a random, completely random thing there, I guess. But those are like empty spots that we can pass things in later to fill in. So it's very useful for maybe consistent, if the output's going to be consistent over like a large data set, and then you don't have to pass it in directly, you can just leave that, and then each particular element in the data set can fill it in as needed. It's like a string with some blanks in it, and we indicate a blank placeholder for that blank with the curly braces. And this one I'll print directly to the screen, because if we return it, it doesn't return quite correctly. But we can print right to the screen with this. It's for output directly. So string with empty spots. We're going to call in that string object, and then we have this method format. And I know we've already seen another method called format that works with numbers. But remember, when we called that method, we didn't have to use the dot operator before. We just concatenated that into sentences and passed in a number. So this, we're going to format. We call that string, and then the format method, and whatever we pass into as arguments to the format method, will fill in those placeholders. So those two that we pass in, some random thing and another random thing. And close out the parentheses here, just to kind of ran out of room on that line, but it's just closing parentheses there at the end. And that'll fill in those spots. So if we run that, call that method FillInPlaceholder, and I just need something to pass in. I'll pass in a couple numbers, 3 and 78.9. You can see it just took that and put those right in that string in the order we've passed them in. FillInPlaceholder. Blah, blah, blah. passing in a couple strings this time. And you can see it just took those strings we passed in and stuck them right in that place, those placeholders. Kind of remember, we're going to close this for the next one. And this next one's really just an extension on that. So define a method called IndexedPlaceholder example. That fits the naming convention. At least 3 words in all caps notation. Again, I'll pass in 2 things. So some random thing, another random thing. And it'll look almost exactly the same. And actually, I'm just going to copy this. Control C, down here, Control V to paste it. And the only thing I'm going to change is I'm going to add indices in here. So an index for this first one, I'm going to go out of order. Whoops. My 1 key is still sticking. 1 and a 0, just to kind of switch it up and go out of order. So save and run that. I'll call the first one FillInPlaceholder, just to have that on the screen. I don't know, the 3 and what did I do last time? 55.4, some sort of number. And the first one, when we don't put any indexes in there, it just, the order we send them is the order it fills them in. And the second one, which I forgot what I called, IndexedPlaceholder example. IndexedPlaceholder example. I'll pass in the same thing, 3, 55.4. You can see this time we index 0 of what we passed in. The first thing we passed in, we said index 0 goes over here. And the second thing, we said that index goes over here. So that is very, very useful when you have a large data set and all the outputs are going to be the same. And you can just kind of leave some blanks in a string and fill it in later. Okay, the next one here, close that to get out of the way. Next one here, we've seen these a couple times. I just wanted to make sure and explicitly mention them in the section about strings a little. Defines a method called sum escape sequences. We don't need any parameters on this one. And I'll just print out a string, throw in a couple escape sequences. So maybe something like, here is a new line, which I believe we've seen \n gives us a new line, and a tab /t character. Come down, oops. Come down to the next line, plus, well, I'll do another new line, and a quote, and a \. So we've seen these before, I believe. \n gives us a new line when we're working with text. \t for a tab. Well, quote marks, that's obviously used in the string. So if we want to put a quote mark, a quotation mark inside of a string, we need an escape sequence to call it up. And well, since \/ is used to call up our escape sequences, if we want to actually put a \, we're going to need that as an escape sequence. There's a long list of them. Yeah, there's a long list that you'll, in the 200 level class, they usually we'll go over it in a lot more. We kind of expect more to be known, but new line, tab, that works nice for formatting, and quote marks are probably the three that get used the most often. But most any of our escape sequences, those special characters that we have to do something specific to include, is going to be like that, a backslash to get to it. So if we run that, let's see, I called that method sum escape sequences, not passing anything in. So here's our new line, and it gives us a line break. You see the tab, we can see it right here, there's no spaces or anything, just that backslash T between tab and character, and it put that whole tab symbol, several spaces in there. To include a quote mark, obviously that we need that to create a string, so if we want to include a quotation mark, make sure you use a backslash. And languages like Python, where single and double quotes are interchangeable, we can get one level deep, right? We could start our string with double quote marks and then use single quote marks inside it, or vice versa. We could start our string with single quote marks and then use a double quote marks inside it, but we can only get one level deep. So it's better form to go ahead and use, anytime you want to put a quotation mark inside of a string, use an escape sequence. Probably best just to get in the habit of that now. But there's a long list of escape sequences, things that the computer is going to misinterpret when it sees that symbol, right? Like a quote mark. We want a quote mark here, but we don't want that to be the end of the string. We just want a quotation mark in the string. So the computer would misinterpret it. So we need anything like that, we need an escape sequence. There's two more I want to cover here. Yeah, there's two more I'm going to cover here, and this list is what I come up with as far as what gets used the most. So I thought I'd start with that list. The book has a few different ones. An exhaustive list of these would be completely overwhelming at this level. There are still lots and lots and lots and lots of them to come. Lots and lots and lots and lots of built-in methods to work with strings. So the exhaustive list would be completely overwhelming. These are the ones I thought kind of show up the most often. And these last two I saved for last because these are the two that we'll most often use with regular expressions. So I'll start a new file and probably drop the naming dimension for that in the example and go with, I usually use camel case most often and go over regular expressions, but I'll do that in a different file. These two are the two methods that go with regular expressions most often. So let's see, I'll call the first one look for something. Pass in some sort of string parameter to look through. And essentially this is like Control F, pushing Control F on the keyboard. That's what this is going to do. This is the programming language version of Control F. So a string parameter, so that string object we passed in, like all objects, has the built-in behaviors, the behaviors it needs built in. So let's find I haven't made up, I'll make up a string when we get back over, when we run this, and I'll just make sure I put something with the in it or one without the in it. And that just looks for that particular word or that combination of characters. The computer doesn't know what the word the means. It's just going to match character for character there. So run that. Call the look for something method. A string to test the method. Make sure the word is in the first one. So it returns 17. So that returns the index of where that starts. We come over here, 1, 2, 3, 4, I should start at 0. Count indices. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you can see that returns the index of where it starts at. Look for something, a string without that word. And if it is nowhere in the string, notice it returns -1. So usually when we use this, we'll put something, assign it to a variable. So x equals, look for something, a string, and then we can check that. So if x is less than 0, then that would mean it didn't find it. Print didn't find it. Else print at plus at index plus x. So it's not in that string, so you didn't find it. I'll copy and paste. Let's say what x equals, look for something, string to test the method. So it should be in there, and I'll just copy and paste this. Control C, Control V, oops. Why is it giving me? I'm not sure where that syntax error came from. I'll run these one at a time. Control copy, Control paste. So that one ran. Then I'll copy this one. Oh, I copied an extra line there. That's what happened. Well, might help if I copied the right thing. Control copy, Control paste. So now X definitely has the word the in it. And I'll copy and paste this. Control C, Control V. Paste that back in again. And cast that as a string. Try to do a quick example. It didn't quite work. At least not quick. There we go. So if it's not in the string, sorry, that was the one way up here before all the errors, it returns -1. If it is in the string, it'll return what index it is. Close all that out there. Sorry about those errors. I probably should have thought about that before I went and did it. The last one is kind of the same. So find and replace. I guess I called that previous one that said that's like Control F. So this is like Control H here in Python in idle. Not always Control H, but in a lot of text editors it is. So some passed in string. This is like Control H. We're going to find a word, not just find a word, we're going to replace it with something else. Return passed in string replace, oh, I don't know, just for an example, replace any letter E with a bunch of capital E's. Completely random example there. If we run that, I'll find and replace. Here is a string for testing. So our string here has a couple E's in it, there and there, another one over there. So it should replace all of those with a long string of capital E's. You can see it just, once it sees that letter, it matches it and replaces it. And those last two, we will use those a lot with regular expressions. So I'm going to start a new file and work and kind of take a first look at regular expressions here. But these are the ones, the methods with strings that I think get used the most often. From my experience, it seems like these show up more than others. The book has some other ones. The exhaustive list is huge. It would take several hours just to say what all of them are. So just kind of starting out, and these are the ones that I think are most useful to know. I guess we could relate this to that earlier list I gave of the things to learn about a new language. On that, I put strings, and these are kind of the things to know about strings. Well, we always have this. If we work with an array, we have these things. We'll always have those three. But as far as working with strings, the syntax for changing the case and finding the index, checking if it's a number or not. More languages have is not a number function, because the computer can tell a lot better if something is not a number than if it is. Kind of like here, we can only check for integers. That would be a good example of regular expressions. These are putting placeholders in. That's another one that shows up a lot, so that's a good thing to start off with. Yeah, I guess that original list I had of 8 things to learn, I put strings on it, and the syntax for these methods are what I meant when I said string on that list. But hopefully that'll get you started, and the book has a couple others if you want to look at those, or W3 Schools has Python stuff. You can look there, see what methods they have. But again, the exhaustive list is massive. But a few methods to get you started working with strings. So let's take a look at regular expressions. Okay, so just a quick pass here looking at regular expressions. It's not something we need to know at this level, but it can be a little confusing when it first shows up in classes where there's a lot more going on. So I wanted to at least mention it. That way it doesn't catch you completely by surprise when you get to the point where you need to know it, and then there's a whole lot of other stuff going on as well. So I thought I'd do a quick pass and talk about what it is. So like I said on the boards before getting to the examples, regular expressions are string-based patterns of an encoding scheme that we can use to look for patterns in strings. So our module for it in Python is going to be RE, abbreviated for regular expressions. And we look for patterns in strings instead of particular cases. Like we just looked at that method for finding where we would find an exact match. But maybe we don't know exactly what we're looking for. We have a general idea of it. And in that case, we can look for the patterns. So I'm going to start off here with just taking a string, going to pass in some string, and split it up into an array of words instead of an array of characters. Right? We saw how we could take a long sentence or a long string and take each character individually. But relating back to that written language thing, it'd probably be more useful if we could do that on words. So we're going to ask for that regular expression module we imported, and one of the methods built into it is split. And then we'll pass in some arguments. So the first argument is our regular expression. So it passes in as a string. I keep saying string-based. It's a string-based encoding scheme. And we can look for certain characters. If we want a set or collection of characters to look for, we define that with square brackets. So everything inside square brackets is what we're going to look for. Let's see. Let's look for a period, a space, exclamation mark, and quotation marks. So if we see any of those symbols, we're going to split the string we passed up into different things. And the second parameter we have to fill is we need to send some sort of string argument to look for this pattern in, these patterns. Any place we see a decimal, or any place we see a period, a space, exclamation mark. I'm going to come here and make a comment. /S, that's the escape sequence for a space. Does the same thing as putting a space. Oh, my indent level got off there somehow. There we go. I guess it's ASCII character 32, and the computer doesn't know how we typed it. Right? Once it gets down and runs through the processor, the computer is going to know we have ASCII character 32, and it's not going to know whether we typed a space in or typed \S. By the time it gets to the machine, it looks the same, which is an important note on things coming up here. I guess the next video will be into object-oriented stuff. When we get there, an important note is what we type is different than what the computer runs. That's something that shows up in object-oriented programming, often confuses people at first, especially when we get to start talking about efficiencies and things like that. Because object-oriented programming, it'll look like we type less than things that are actually more efficient. So you want to be careful not to associate exactly what we type with what's going on inside the machine. That's an important part later, and typing /S versus actually typing a space is a good indication of that. No matter which way we type it, when it runs through the machine, it's ASCII character number 32. So we'll pass in some string, and then if we see any of these symbols, we're going to split that up into an array. So let's kind of look at that real quick. Oh, I got to save it. Somewhere on a flash drive. Regular expression. And we're just doing kind of a quick pass at regular expressions. You'll need to know them later, and they often catch people by surprise when we're already in a complicated spot, so I thought it might be good to preview them here, kind of get familiar with them. So let's call that method. We'll call the split stuff method, and then we need some sort of string to pass into it. I don't know, here's a string to test with. The expression breaks it up into various elements in a list. I'll put exclamation point in the searching for symbol thing, so I'm going to put that. Determined from I haven't used this yet. Characters, I'll put that in quote marks. We said it. Then end our string. So kind of a long sentence, got some escape sequences here to put quote marks, different punctuation, and for the most part, the words are split up with spaces. So we're going to look for each one of those. Any place we see a period. I guess I didn't necessarily need that here. I'll add another comment down here. Dot inset means dot out of set. So if we don't use the square brackets and just feed in one character at a time, not a set of characters, that means any character. That's kind of going to show up in the second example. It might be a little confusing, but in general, the dot is what represents any character. It's like the wild card. But if we put it specifically in a square brackets in a set, it could mean dot. But for better practice, it's better, since dot is usually the wild card, it's better just to do it as an escape sequence if we want to say dot explicitly. So it's going to split our string up into an array of words rather than characters here. So that's a really useful one that'll kind of show up quite a bit. We enter, or you can see we have a list, a square bracket saying we have a list, and each one's comma separated. So we get each word separated into its own list. And that can be a lot more useful than going through a list of characters. As you can probably imagine, then we have each word and we can deal with them one at a time that way. And we just pass in this string that represents patterns of things we want to do. I might as well copy this. Copy. That way it's, can I do 4 there? Yeah. Run and output. Go ahead and stick that in there so you can refer to it. Might as well split that up a little. So it's readable. There we go. That way you can refer to what it's doing, but we split it up into a list of words rather than list of characters like we would have by default with the string. Come down here, put some white space. White space for scrolling. That way we can keep working in the middle of the screen. And the second example here will show the pattern-based point a little bit better. This one's incredibly useful. There's a lot of times you might want to have each word particular by itself instead of each character by itself. And in that case, you can basically copy this exact thing, maybe throw in some other punctuation. You see, it's just throw them next to each other. You don't need any sort of comma separation or any sort of separation. Just put the symbols you want to split it up at here. And for special ones, make sure and use escape sequences, but otherwise, basically you can copy that exact string anytime you want to do that exact command, anytime you want to do this. And remember to import the module. The next one here is going to show pattern-based stuff a little bit better. Why it's looking for patterns. I was having trouble thinking of an example until working through that earlier section of the video, and I realized that, well, looking for a floating point number, that thing that's kind of missing in Python. The reason it's missing, I kind of alluded to it, is you may have noticed that all of those methods return a positive value, a positive confirmation. They return a positive confirmation, and it's easier to give a negative confirmation. We can say what something is not a whole lot better than we can say what it is. That's why so the other one's kind of hard to get something built in that gives a positive confirmation with all the efficiencies they want internal to the language. And it's not too hard to just set up something if the programmer needs it themselves, like the thing I mentioned that I normally do, or makes a good example of using patterns in regular expressions to look for things. And to avoid a typo here, I'm going to go ahead and type the whole thing, and then we'll talk about it. So we put it in an if statement, so that's what we're going to say if that looks like a floating point number. And to avoid a typo, I'm going to go ahead and type the whole thing. Let's see. I'm going to search through my string, and we want to look for a pattern here. So starts with a character between 0 and 9, ends with a character between 0 and 9. Somewhere in there has a dot, and then that dot is followed by anything that's not a dot. And then probably need to put this one in here. Not a non-digit. I get everything. So starts with digit, ends with digit, dot, immediately followed by not a dot, and not a non-digit. Okay, so, and if it does that, then print floating point, else, I don't know, print. Okay, sorry. Usually I would like to type while talking about it while typing, but you can see there's chances for typos typing normal stuff. I wanted to make sure I got that typed in correctly first. And I'll go ahead and put up what those patterns are saying. So that first part kind of looks like this. That's saying starts with digit. Caret outside bracket means starts. So that's this little part right here. I'm going to say we're looking for check this and see if it starts with a digit. Starts with a character between 0 and 9. Or I guess I should be specific here. Starts with a character in the set, that's what the square brackets mean, that starts at 0 and goes up to 9. That's what the first part means. That second part is kind of the same thing. That's just saying ends with digit. The asterisk outside brackets means ends with. So starts with a digit, ends with a digit. And here we want to look for one decimal, one period, one dot, whatever we want to call that symbol. We want to look for one of those. And this is saying not another dot after it. So if we have a dot that is followed by anything that's not another dot, that'll fit our criteria. So slash dot, not dot, equals one dot followed with not a dot. put here caret inside brackets. That means not. I'll make another note here. Outside brackets. Inside a set of brackets, a dot means a dot. Outside of brackets, dot is wildcard selector. So outside of any brackets, so not included in this, if it's not part of a set, a dot means any character. But inside of square brackets, that means wildcard selector. Which, yeah, I know this is probably kind of seeming confusing, just introducing it, because if you look at this string here, you can probably quickly imagine how you would feel if your first introduction to that showed up in the middle of a really hard section. So I wanted to preview it, that way when you see it in later classes where you'll need it, and you're doing harder things to begin with, it's not going to take you completely by surprise. And the last thing here, so that's saying not, backslash capital D means not a digit. So that's saying no letters in here. Slash capital D means non-digit. Any character that is not a digit is what that stands for. So like always with encoding schemes, like we have with programming, there's more than one way to do this same thing. So let's run that and see if I got any typos. Let me clear this previous one out. So Control S and F5. And we call that find float. Let's try a floating point number, 3.14. Oh, says that's a floating point. Let's try some other ones to see if that worked. 78. That's an integer, not a floating point number. So nope. Find float. Some words got here. That's not a floating point number. Find float. Let's see if that part with the multiple decimals worked. 3.14. Nope, that's not a floating point number. Find float. 3.word4. So starts with a digit, has one decimal, ends with a digit. So here's that not non-digit thing. Let's see if that worked. Nope, not a floating point number. So again, this is kind of preview so that it doesn't catch you completely off guard later. Where'd my cursor go? There it is. Run and output. Kind of showing what that's doing, but you can see we pass in this string of encoding information saying what type of pattern we want to look for. And for this quick example, just a floating point number. Again, we're in preview mode. I did check just a minute ago if time allows. Time is usually running short for all of us, and this isn't necessarily required at this point. It just where it shows up in a harder class is extra harder. So I thought maybe a preview would make that a little bit better. But if time allows, it is an incredibly useful thing to know. I went to Google, searched regular expression in Python. I should put that in quote marks. Search regular expression in Python. The W3 schools had a good intro. So a good bit to get you started. Again, it's a big, complicated thing, but at this level, just kind of get started on it. This line will be incredibly useful. So yeah, go ahead and copy and paste that line, because having your words, having a list with your words as elements can be incredibly useful. This one is more of the preview. See, we can search for things that match these patterns, and regular expression, that's what regular expressions are used for. So hopefully that wasn't too confusing. And yeah, my main goal there was that hopefully that makes it a little easier when that shows up in a complicated section in 200 level class. The 250 or 264 class are the ones springing to mind, because where it actually details that. So hopefully that gives a bit of a preview for it. Incredibly useful, and it's across the board. Regular expressions are available in almost any language. They're not built into Python. In Java, for those who are going to take that for their 200 level class, regular expressions are built into Java. So any of your methods about string objects can use regular expressions directly in Java without anything special. But they're not built into Python, so we have to import the module and work with them here. But you can check there if you want to go a little bit further. In general, it's just a preview or some boilerplate code. Copy and paste that line, and maybe add some more symbols in there where you would split words up, because that one's useful. And that's kind of the gist of strings. Hopefully that helps get you a good start working with strings. Strings themselves are written language, so you should be familiar with that by the college level here. And the next section, next video lecture, we're getting into object-oriented stuff.